Temperature is another important conversion factor that can be used for boiling points, melting points, and a whole bunch of stuff. There are three main temperature scales that we're going to use in chemistry: Fahrenheit, Celsius, and Kelvin. And they're all named after the people that kind of developed them. Now, what we're going to do most of the time in chemistry is we will make measurements in the lab in Celsius. And for calculations, we'll convert the Celsius temperatures into Kelvin temperatures and vice versa. On the other hand, we live in the US of A, in good old Oregon. And Oregon, if you watch or listen to any of the news channels, they're always recording temperatures in Fahrenheit. So you must know how to make conversions to your regular life. You must know how to go from Celsius and Kelvin to Fahrenheit and vice versa. We won't use Fahrenheit very much in this class. It's not a very useful unit for science, as we'll see. But Celsius and Kelvin are going to be the two main ones, but we are going to know how to go back and forth and stuff like that. There's a relationship between the three temperature scales and the freezing points and boiling points of water. So if you grew up in that good old Gresham, Oregon, like me, well, water freezes at 32 Fahrenheit, water boils at 212 Fahrenheit, and the difference between them 180 and stuff like that, and that's fine. However, Celsius and Kelvin have a lot of advantages. Celsius, water freezes at 0 Celsius, and it boils at 100 Celsius. And notice that the difference between those is 100 degrees. 100 minus 0 is 100, all right? Kelvin, it's a little weird at first, but there's 273.15 where water freezes and 373.15 where water boils. And the difference between those is also 100 degrees. So because the difference is the same, a degree Kelvin change is the same as a degree Celsius change. And that's going to be so cool to us later on. I can't even begin to tell you. Fahrenheit, because it's 180 degrees difference, you're going to have to make some weird kind of conversions and stuff. So scientists will usually, like I said, record temperatures in the lab in Celsius. And for calculations, we're going to see there's uses why Kelvin is better for calculations. So easy to convert one to the other. But Fahrenheit, it's going to be a lot different. So no problem. So try to use Celsius and Kelvin in the lab. In your real world, you can use whatever you want, all right? But in this world and stuff, use Celsius and Kelvin. So here's just examples: 100 Fahrenheit, 38 degrees Celsius, 311 Kelvin. Water, 32 Fahrenheit would be 0 Celsius, 273 Kelvin. A couple things about Kelvin. If you haven't seen this before, Kelvin for our uses in chemistry will never be a negative number or a negative or even 0. All right, Kelvin is always a positive number. Kelvin scale represents the place at 0 Kelvin where all matter stops moving. And in theory, that should be impossible. But there are some experimental kind of theoretical things going out there where maybe you can have negative Kelvin. And that's really cool, just like I like talking about science fiction, but that's not appropriate here. So for Chem 221 through Chem 223, no negative Kelvin temperatures. Also, officially, there's no degree Kelvin. If you look at the scales down here, like it's degrees Fahrenheit and it's degrees Celsius, but Kelvin doesn't have that little symbol. So Kelvins aren't supposed to have degrees. And a lot of times in astronomy and in photography, they'll use these degree Kelvin symbols, and it makes my chemist's hairs in the back of my neck stick up, but they're not supposed to do that. So try to not use degree Kelvin if you can help it. Here's an example. Again, my jokes. This is Foxtrot. It says recipe says to bake the cookies 350 degree oven for 14 minutes. And sorry, I'm cracking myself up. And I've read this comic several times anyway. Does it mean degrees Fahrenheit or degrees Celsius or degrees Kelvin? And then the brother comes in and goes, maybe you should just rotate the oven just shy of a full circle because a circle is 360 degrees. And this brother goes, don't be ridiculous and stuff. Anyway, it shows the importance of knowing what type of scale you've got, all right? Because 350 Fahrenheit is quite a bit different than 350 Celsius or or 350 Kelvin, absolutely. So knowing what type of unit is important. Now, probably in this one, because again, this is a US of A comic, it was probably 350 Fahrenheit, but on the real world, you should be really careful. And of course, if you have a recipe from Europe where they use Celsius, it might be in Celsius, so just be careful. If you're going to convert Kelvin to Celsius, Celsius to Kelvin, it's pretty chill. You want to use that 273.15. And again, remember that Kelvin temperatures will never be negative. So if you end up with a negative Kelvin temperature answer, and this is and you're in a chemistry class with me, then probably the calculation is wrong. But Celsius can be negative. So to the temperature in Celsius, you want to add 273.15 to get the Kelvin. And of course, if you have Kelvin and you want to go to Celsius, you would subtract 273.15 from the Kelvin temperature to get the Celsius temperature. So body temperature, about 37 degrees Celsius. Wonder what that number is in Kelvin, Dr. Russell. Let's figure it out. Celsius plus 273 is how you do it, 310. Now, notice I didn't put the 0.15, and I added a little dot right there. Both of those are intentional, again, based on significant figures. And we're going to talk about that here in a little bit, I promise. But we're not there yet. So for right now, just bear with me. 37 turned into Kelvin, 310 with a dot Kelvin temperature. Liquid nitrogen, very, very cold. Terminator 2 froze the Terminator down, stuff. Anyway, temperature of liquid nitrogen, minus 196 degrees Celsius. Remember, Celsius can be negative, but Kelvin won't. So if you wanted to turn that into Kelvin, you'd add 273 to it. 77 Kelvin would be the liquid nitrogen temperature. If you have to use Fahrenheit, totally legit. It's kind of a drag, but anyway, what I would do is if you're starting with Celsius, you want to turn to Fahrenheit, you multiply the Celsius temperature by 9/5 or 1.8, and you add 32. Some textbooks you'll see the 1.8, some textbooks you'll see the 9/5. It's the same thing. Whatever you want to do is fine. 1.8 times the Celsius temperature plus 32 is it. So, liquid helium, 4.2 Kelvin. If you wanted to turn this into Fahrenheit, what I would do is I would go Kelvin to Celsius first, and then Celsius to Fahrenheit next. Now, Fahrenheit can be positive and negative just like Celsius, but again, Kelvin will not be. So, Kelvin minus 273.15, you get negative 269.0 degrees Celsius. And yes, I am including that 0.0 for a reason. Yes, it has to do with significant figures. We'll talk about that here in a little bit. Anyway, for right now, knowing that's the sig fig answer, if you wanted to convert that Celsius to Kelvin, you would throw that into the 9/5 times the Celsius plus 32. And when you get this out, negative 452.1 degrees Fahrenheit is the temperature of liquid helium. And that is really, really cold. Brr. But anyway, again, Celsius to Kelvin, Kelvin to Celsius a lot, once in a while Fahrenheit. So here's temperatures that you can read, that you can actually experience on the Earth. 29 Celsius, 45 Fahrenheit, 256 Kelvin. Let's put them in order of increasing temperature, all right? What I would do in a problem like this is use Celsius as the halfway. So I would turn Kelvin to Celsius, and I would turn Fahrenheit to Celsius and see which one it is. So in this particular one then, 256 Kelvin, you would subtract 273.15 from it to get the value. That's going to be something that's pretty cold. It's going to be a negative number. So 256 Kelvin will definitely be colder than 29 degrees Celsius. Now, Fahrenheit, 45 Fahrenheit, if you wanted to turn it in, you would first subtract 32 and then divide by 1.8 or 9/5. And you'll see that that value is also smaller than the 29 Celsius. So of those, the 256 is smallest. It's going to give you a negative Celsius. 45 Fahrenheit won't give you a negative, but it will be a smaller number than 29. So 29 would be the largest. Again, in your studies, make sure you know how to go Kelvin to Celsius, Celsius to Kelvin, and just know that there's a way to go from Celsius to Fahrenheit if you need to.